So another day and another big picture, and the picture we're going to talk about is the relationship between electrical frequency and magnetic field rotation. What do we mean by electrical frequency? We mean the frequency of the three-phase current that we are supplying, and we're going to relate that with magnetic field rotational speed or frequency. Okay. So what did you learn last time? We learned that how to produce rotational magnetic field by three-phase supply to a three-phase set of windings, and remember that the same phase windings will be 180-degree apart, and the windings with like polarity but different phase will be 120-degree apart. Alright, and this is the waveform of a three-phase sort of current, and this is IA dash. This is the minus 120-degree lagging phase, and this is the minus 240-degree lagging phase. You are gonna supply the 0-degree phase to IA dash, coming in, coming out, coming into A dash and going into A, and we are going to supply the minus 120-degree lagging phase to IB B dash, again coming out from B dash and going into B, and we are going to supply minus 240 lagging phase to C dash, and again coming out from C dash and going into C. So we're gonna see at some particular time p x and another p dash what's happening to the current, and how's happening to the magnetic field due to the current. Alright, so let's consider at some particular time p. At some particular time p, you see that only ia dash is positive, right? If ia dash is positive, that means the initial direction of current is holding, right? But all the other thing IBB dash and ICC dash, they are negative, so initial current direction which we have assumed would be reversed. So this will, here it will be coming out, here it will be coming out, here it will be going in, and here it will be going in, right? That's how it goes. So if we apply our right hand now, you see for current coming out in this winding, the magnetic field will be like this. For current coming out in this winding, it will be again like this, and here it will be like this. Just a simple use of your right hand, and here going current going in, so the magnetic field direction will be like this. If we add up all the resulting magnetic fields, we see that we get a magnetic field which will go in this direction, right? Because all the magnetic fields are going in this direction. It's coming from this side and it's leaving in this side. So what's the pole we decide for the entering portion of the magnetic field? We say that's the north pole, and we say this is the south pole with which the current is leaving. Alright, so that's the idea of two pole, basically, that you get a two pole sort of things, and we'll see how that poles are getting rotated with time. Alright, here we are going to consider another time being, and the time being is x, and in that time being you can see that only IBB dash is going to be positive, IAA dash is negative, and ICC dash is also negative. So the direction of B and B dash are going to hold, but the direction of A dash and A are going to change. So this is where it goes, and the current direction of C and C dash will also change from initial. Sorry, yeah, that's how it goes. Alright, so if we again apply our right hand right now, you see the magnetic field direction, just apply it like our first example. The magnetic field direction will be like this. So what will be our north pole? Our north pole will be shifted in here, and this is going to be our south pole. You see that our north pole has rotated. As time increased, our north pole has gone some angle in the counterclockwise direction. This is why we say that poles are moving in counterclockwise way. Alright, what will be at some moment p dash afterwards, which is equivalent to p? That means here also IA dash is positive, IBB dash is negative, and ICC dash is negative. So all the scenarios are going to turn out the same, right? And we will get the same sort of magnetic field. This is north, this is south, alright? So we see that from this P to this P dash we have considered 360-degree rotation, right? After 360-degree rotation we see this north pole first started rotating counterclockwise, and after 360-degree rotation it had completed a full rotation and came back to its original position. That means its rotational angle is also 30 degree, 360 degree. So that's what is written here. After, so what can we conclude? That in some time period the angle covered by the magnetic field is equal to the angle covered by electrical current, and so that obviously means that their frequency is going to be the same, right? And also the angular frequency along with the linear frequency. So here is the idea of two-pole stator. You can see that how poles come into play in induction motor. We will generalize about p-poles and and more poles, how to make more poles later in the video. Alright.